Hello friends. Now from this diagram, the students of the environment or the students of chemical and civil branch or the industrial people are knowing that this is a example of effluent treatment plant, or it is a similar example of sewage treatment plant. Sometimes we are referring a separate ETP, sometimes we are referring a separate STP, and sometimes some designs are the combination of these ETP and STP in a single layout. So this is the layout of the effluent treatment plant. So we have to discuss what exactly the effluent is, what exactly the treatment facilities are, what are the steps which are involved in the ETP. So ETP is one type of wastewater treatment method. So in the ETP, that is effluent. So normally when we are talking about the effluent, it is a trade effluent. When we are talking about the trade effluent, it means it is generated by the industries, right? So it is the treatment method or the treatment plant facility which is focusing to treat the trade effluent or the effluent of that industry, which is particularly designed to purify the industrial wastewater for its reuse, and its aim is to release safe water to the environment from the harmful effects caused by the effluent. So effluent may have different characteristics, and due to these different characteristics, they may damage, they may adversely affect on the environment or to the river bodies which is nearby to that industry or to the MIDCs. So to reduce the adverse effect, to reduce the severity of that particular property or the characteristics of that effluent, we have to treat this effluent in a such a way that we can reuse this wastewater in a different purposes, or we can at least reduce the characteristics or the property of that effluent which is harmful to the environment, which is harmful to the human beings. So this is the main purpose or the basic purpose of the effluent treatment plant. Industrial effluents contain various materials depending on the industry, because the industrial types are different one. Some are chemical industries, some are engineering industries, some are packaging industries, some are pharmaceutical industries, some are only assembling industries, some are manufacturing industries, some are formulation units, some are bulk drug units, etc. So depending on the type of industry, depending on the materials which are used in the industries, depending on the processes which are involved in that industry, the type of effluents is generated. So we can easily understand, especially when we are talking about the chemical industries, when we are talking about the bulk drug industries, when we are talking about the pesticide industries, when we are talking about the oil or related industries, then there are chances of toxic release in that effluent, and they required a special treatment methods, right? So some effluents contain oil grease, some contain toxic materials like cyanides. Effluent from food and beverage factories contain degradable organic pollutants. Since industrial wastewater contains a diversity of impurities, and therefore a specific treatment technology called ETP is required. So when we are talking about this effluent treatment plant, there are various designs available for this ETP, but depending on the characteristics and the properties of your industry, the design should be selected in that way only, because a general ETP is not appropriate for all types of industries, because you can understand that these various types of industries generating the various types of pollutants in that effluent. The ATP plant work at various levels. and involves various physical, chemical, biological, and membrane processes to treat waste water from the different industrial sectors like chemicals, drugs, pharmaceuticals, refineries, dairy, ready-mix plants, and textile, etc. So I have mentioned here the specific industries which are generating the high quantity and more serious toxic effluent in that industries, right? So these industries are required a specific type of treatment in the ETP plant. So in general, when we are talking about the effluent treatment plant, so this is the general flow or the flow chart which is accepted by the all types of industries and the designer people or the professional people who are going to design these ETP setup. So this is the influent, that is nothing but the input of that trade effluent. So whatever the liquid or the wastewater generated by that industry is nothing but the influent for this ETP, right? So this influent, whatever the quantity, whatever the flow rate, we have to take care of all these parameters. We have to send this influent to the screening facility. So the screening may be the bar facility, that may be a fixed facility, that may be a variable or portable facility, that may be a hydraulic based bar facility. So depending on the facilities required by your industry, though this screening is required, but screening is nothing but the facility to separate out these solid particles or the floating materials or the large size particles from this influent. That is simply called as screening. Then equalizations. So in this equalization tanks are available. So in the equalization tank or equalization facility, so these influents are uh, sent to this equalization tank for the settling purpose. In these equalization tanks, due to the less velocity of this influent, the large particles or the flocculants or the flux or the high gravity and having more mass particles are settled down due to the gravity at the bottom, and the clean effluent is sent to the coagulation. So some particles or the salts or the solids are dissolved in the influent, and that is why, which is not settled by the gravity itself in the equalizations, are now going to settle in the coagulation or the flocculation unit. So the coagulant and floc. So these are the words which is used in this process. So if you are going to use a coagulant for settling the solid particles in the process, that is called as coagulation. So coagulant may be the alum or the alum derivatives or the different chemicals are nowadays using as a coagulant for collecting. So what exactly the process is? So the property of that chemical which is acts as a coagulant is inserted in that tank, in that influent, and due to the property of that coagulant, they are attracting the small size particles towards the coagulant, and these small size particles are collected together and they have settled down at the bottom due to the gravity, because as the particles are attracted to the alum or the derivatives, that is the coagulant, so that mass of that substance is going to increase, and due to the more mass, these particles are going to settle down. In a similar way, if the flux are generated in that tank, then these flux that is having more density and more volume are going to settle down. So in the equalizations, in the coagulation and the flocculation units, we are going to separate out these solid particles from the influent or from the liquid particles. Then there is a tube settler for settling these types of different particles. Then there is a biological reactor. The biological reactor may be 1 unit, 2 unit, 3 unit, depending on the quantity of the influent. So biological reactor may be a membrane reactor, that may be a other reactors which is based on the biological activities. So nowadays the rotating biological reactors are using in some of the units, the membrane reactors are used, and in some of the units only the biological activities are done in that reactor, that is also called as biological reactors. So in these biological reactors also we have to separate out and settle down some of the biological agents from this influence. Then there is another tube settler which is sent to the collector tank, and after collection of this influence and depending on the characteristics, because in each and every outlet of all these tanks we can easily collect the sample. We have to analyze all these samples, and depending on the results of this sample analysis, we have to uh, send these influent, or we have to send this wastewater to that particular tank. So from this collector tank we can send it to the activated carbon filtration. So normally it is charcoal or activated carbon. So nowadays we are using the automated doser of these activated carbon filtration units. So depending on the quantity, depending on the characteristics of the wastewater which is came from the collection tank, is analyzed by this activated carbon filtration unit. So I am talking about the latest automated unit. So depending on the characteristics, depending on the quantity, these activated carbon uh, quantity and the quality of this activated carbon is used for this filtration purpose. So in the conventional technique, it is simply this wastewater is going to pass through these activated carbon beds, and the characteristics of this activated carbon is they are going to absorb the colors, odors, or the different impurities from this influent or from this wastewater. So after absorbing this color, odor, or the different impurities from the wastewater, they are going to send to the sand filtration. So whatever the impurities, whatever the solid particles which is not adsorbed, which is not collected in the coagulation, flocculation, or equalization tank, which can be blocked by this sand filtration or the sand bed. So the different sand particles or different sand size particles are used in this sand bed, and after blocking these impurities from the sand bed, the clean water or the treated water is prepared. So this is the influent flow from this point to this point. Now there is another path, that is from the tube settler to. So depending on the characteristics again, if it is a semi-solid or more solid having liquid particles, wastewater, then they can send it to the sludge pit. So if you observe that this wastewater can generate easily a sludge, then you can send it to the sludge pit, or from this tube settler 1 also, or from the tube settler 2. So if the semi-solids substances are there, or if you observe that after evaporation of the water, this sludge can be prepared, then you can send this wastewater from tube settler 1 or from the tube settler 2 to the sludge pit, and then with the help of this clarifier you can easily send to this wastewater, that is you can easily settle down these solid particles in the clarifier, and the clean water or the clean liquid is going to send to the other equipment. So the sludge can be prepared by removing the water from this clarifier. So you can separate out this water, you can remove this water from this sludge plus water mix, and if you success in removing this water, then the sludge can be prepared. So this sludge is nothing but a natural fertilizer which can be used in the farming or in the other purposes. So you can dry this sludge also with the help of sludge drying bed facility in the sunlight, and you can sell this sludge or dry sludge to the different farmers or the persons who are interested to buy this. So this is a common effluent treatment facility, but depending on the characteristics, suppose if your effluent is not going to generate this type of sludge, then this arrow and this arrow is not applicable to your ETP, right? So only effluent to the treated water, this path is going to follow by your ETP. Then this is another picture which is clearly shows you the facilities like pre-primary, primary, secondary and tertiary facilities in this treatment plant. So screening, then grid chambers, then settling tanks, then membrane reactor or membrane biological reactor, then another settling tank for the sludge, then the filtration units, then chlorine unit for the disinfections and the recycle water. For the sludge facilities, the sludge may be created with the help of these settling sludge tanks, then thickeners, then stabilization, dewatering facilities, then with the help of sunlight, we can dry this sludge, and after drying this sludge, we can sell this dried sludge as a natural fertilizer to the interested parties. So industrial effluent treatment processes having these stages like preliminary treatment. So we have already discussed about the screening, so that preliminary treatment is nothing but a screening purpose. So if you want to separate out the large size contaminants, for example cloth, paper, plastic, wood logs, etc., then we can go for the screening. So this is the first unit operation that occurs in wastewater treatment plants. A screen is device with uniform openings and its purpose is to remove large floating solids. So this is the actual photographs of the preliminary treatment, that is nothing but the screening. So depending on the type of or the characteristics of the effluent, we have to adopt these types of screening. So this is the simple bar rack, and this is the another design. This is a specific design. So here small size particles are also blocked in these type of designs, and this is another bar rack designs. Nowadays this is operated by the hydraulic systems, and even after blocking these particles, we can easily convey these particles from this point to the vertical points. So all these different or latest types of designs are also available in the screening. Then another preliminary treatments are sedimentation, then grid chamber and clarifiers. So sedimentation, we normally know what exactly the meaning of this sedimentation is. So we have to settle down the different solid particles with the help of gravity. That is called as sedimentation. So suspended solids from the water are going to settle down with the help of gravity is sedimentation facility. So different types of sedimentation tanks are available in the ETP. Then the grid chamber facility is there. This wastewater that moves into the grid chamber removes the dense inorganic solids such as gravel, metal fragments and sand which have made their way into the sewers. So removal of the grid can prevent damaging of the pumps and operational difficulties. So removal of this grid in that particular equipment is called as grid chamber. Then there is another equipment which is used for this preliminary treatment, that is called as clarifier. So these are the tanks built with the mechanical means for continuous removal of the solids being deposited by the sedimentation before the biological treatments. So the large size particles are blocked by the screen. Then some particles can be removed by the gravity in the sedimentation, and some of the grids are removed by the grid chambers, and the remaining one can be settled down before sending to the biological treatment in the clarify. So these are the different preliminary treatment facilities available in the normal ETP. Then the next one is primary treatment. So the aim of this primary treatment of floating, that is removal of the floating and settleable materials such as suspended solids and organic matter. In this treatment, both physical and chemical methods are used. So it includes flocculation, coagulation, and these are the different facilities. So we have discussed about these flocculation and coagulations. So I am repeating in short. Flocculation is a physical process and does not involve the neutralization of charge. It involves the addition of destabilized particles together into the large aggregates so that they can easily separated from the water. And in the coagulation, it is a process in which coagulants are added for the purpose of rapid settlement of minute solid particles or minute solid particles in a liquid into larger mass. It permits particle removal by the sedimentation and for the filtrations, which is shown in this picture. So this is the primary treatment facilities, that is clarifier tanks. So normally it is a cylindrical tank or a rectangular tank. This is the pump facilities, and this is the area where the actual primary treatment is going on. The clean liquid is collected in this space. So here it is a gap. So in this gap, with the help of V notches facility, so whatever the large size particles or the solid particles are going to settle at the bottom, and the clean water is going to separate out in this primary treatment. And then this clean water is going to send to the next tank. So neutralization is the facility. The main purpose of this facility is to help the pH range. So to maintain this pH range between the 6 to 9 to meet the requirement of the different processing units in the ETP systems, primary clarifiers, these are used to show the velocity of the water to point where organic solids will settle down to the bottom of the tank and contain the an equipment that is used to remove the floating solids and greases from surfaces. So neutralization is the technique. Neutralization means we have to maintain this pH near about 7, because this pH is ranging from 0 to 14 and the midpoint is 7. So for maintaining this pH near about 7, the process is called as neutralization. And the next treatment process is secondary, or it is also called as biological treatment. The objective of this treatment is that from the primary treatment, the wastewater is going to send to the next one, that is biological treatment, to remove the suspended solids and the residual organics. In this step, the biological and chemical processes are involved. So normally the main process is biological treatment. So that may be an activated sludge process. This is used for treating industrial wastewater using air and a biological flock composed of bacteria. So nowadays there are different sophisticated and latest research based technologies and processes are used under this biological treatment. So this is one of the conventional process, that is activated sludge process. So we have to prepare activated sludge with the help of biological treatment. So this diagram clearly shows you what exactly the secondary treatment is or the biological treatment is. So the wastewater which is coming from the primary treatment is sent to the biological treatment unit, and maybe with the help of some bacteria or the added bacteria, depending on the type of characteristics, we have to use these membrane bioreactors, and then with the help of this biological treatment tank facility and membrane bioreactor, this wastewater can be sent to the next treatment facilities. So this diagram shows you that before the membrane facility or the membrane bioreactor, these are the untreated wastewater contaminants. That is, different bacteria are available in this wastewater, and in the membrane, it is the facility that we can block these bacteria, we can avoid this bacteria to pass through this membrane. So the size of the membrane, the membrane type, the membrane material, all these things decided the efficiency of that membrane reactor. So normally these types of bacteria are blocked in this membrane bioreactor, and the clean water molecules are sent to the next facility. Then we can also use the aerated lagoons, trickling filters, and RBC, that is rotating biological contactor, under this biological treatment facility. In the aerated lagoons, it is a treatment pond provided with the artificial aeration to promote the biological oxidation of wastewater. Now in this biological treatment, we have to keep the record of the dissolved oxygen, because if the dissolved oxygen level is less than 4 mg per liter, then it is harmful to the animals which are present in the river bodies, because these, after the treatment of this biological treatment or the treated water, we can send this treated water to the different river bodies. So to maintain this dissolved oxygen level, to maintain a good atmosphere in that wastewater, we can use this aerated lagoons. Aerated lagoons, it clearly mentions that aerated means we have to supply the air. That may be a natural, that may be a artificial one. So if it is artificial well, then we have to provide the fan facility or the blower facility for adding this air. Indirectly we are adding this oxygen into the wastewater. So if the oxygen level is more, obviously that wastewater can be treated. So this is the aerated lagoon. So this is the open ponds which is used as a aerated lagoon. Then there is another uh, filter, that is trickling filter. It is also known as sprinkling filters, are commonly used for the biological treatment for domestic sewage and industrial wastewater. So it is used for both purpose, that may be used for in the sewage treatment plant facility, and that is also used for the effluent treatment plant facility, that is for the industrial wastewater. So what exactly in this trickling filter is? So this is the diagram of this, or the picture of this trickling filter. So in this trickling filters, we are spraying this wastewater into the air, and this wastewater is going on this sand. So this is the different size sand is available in this filter, and this sand is going to block the different impurities from this wastewater. So this wastewater, when we are going to spray in the air, obviously the air indirectly the oxygen is added into the wastewater and the impurities is blocked into the sand. So both the purpose of this filter is going to solve. We are also adding the oxygen or the air, and we are also going to block the impurities with the help of this trickling filters or the sand beds. Then there is another facility, that is RBC, rotating biological contactors. It involves allowing the wastewater to come into contact with the biological medium in order to remove the pollutants in the wastewater before discharge of the treated wastewater to the environment. So for the biological treatment, we can use this RBC. So this is the RBC photograph. You can understand that wastewater can send to these different medium, that may be a biological membrane, that may be a different types of media where the biological treatment can be carried out. And after the treatment, this wastewater can be sent to the next process or the next step. So this is the biological medium which is available in the rotating disc or rotating membranes, and it is going to rotate with the help of this motors, and that is why it is called as rotating biological contactor. Then the next treatment, preliminary treatment, primary treatment, and the secondary treatment. The most of the wastewater is treated, and if again some of the impurities are involved, some of the bacteria or the bad bacteria are available, or the negative bacteria are available in the wastewater, then that should be treated in this next treatment process, that is called as tertiary or advanced disinfection treatment. So we can go for the chemical coagulation and sedimentation, or for the filtration, for the RO systems, or for the UV inspection. So these are the different facilities available for the tertiary treatment. Depending on the characteristics of the effluent, we can use these facilities. So chemical coagulation and sedimentation, it is used to increase the removal of the solids from the effluent after the primary and secondary treatment. So even after the primary and secondary treatment, if there are solids which is retained in that wastewater, then we can go for the chemical treatment, and with the help of these chemical coagulants, with the adding of these chemical doses, we can go for the sedimentation. So chemical doses additions, that is chemical coagulation and sedimentation. So this is the simultaneous activity for removal of the solids after the primary and secondary treatment. We can also adopt the filtration facilities, that is the clarified wastewater is first passed through the adjacent filtration plant, which contains large filter blocks to ensure high quality water. So we can use the large filter blocks to ensure the high quality water which is required by that particular industry or particular party. So if you want to go for the hi-fi filtration units, then you can adopt this facility. In some of the industries, we have to use these RO facilities. This is nothing but the reverse osmosis. So in this process, pressure is used to force the effluent through a membrane. So this is the membrane separation technologies which is used in the RO. So that retains the contaminants on one side and allows the clean water to pass to the other side. Normally, when we are using the cylindrical membrane facilities in the RO systems, then we have to pass the effluent or the wastewater after the secondary treatment should be passed from inside, and this should be passed to the outside. So from inside to outside, the pressure is required to flow this wastewater, and that is why the motor requirement is there or the pump requirement is there to operate these reverse osmosis facilities. But when these total dissolved solids are present in the wastewater, and if you want to remove these total dissolved solids, then this is the best method to use, that is called as reverse osmosis. Then in the wastewater, if some material or the negative bacteria are present which can easily infected to the animals, to the human beings, then that should be removed from the wastewater, and that is why this UV disinfection facility is there. It means you are going to use the ultraviolet light in that facility, and we have to pass this wastewater from this disinfection unit. So this is the simple facility that one UV light is there and we have to pass this wastewater. So the characteristics of this UV light is that they are going to kill or they are going to uh, deactivate many of the bacteria which is present in the wastewater. So all these facilities are shown in these pictures. So this is the reverse osmosis facility which I have already discussed. These are the membranes and these are the pump facilities and control panel for activations. So depending on the quantity of the wastewater, we have to use the number of membranes, the quality of membrane and the material of membrane. Then this is the simple UV disinfection facility. This is the UV light source and we are going to pass this wastewater from this end, and with the help of this UV light we can easily deactivate the bacteria which is present in the wastewater. So this is the water outlet. Then this is the facility, that is hi-fi filter facilities or backwash facilities also available for the filtration. When you are using the high quantity of this wastewater, then and then only we can go for this backwashing facility. It means we can use the filter again and again by removing these solid particles or the impurities which is present in that filter. And this is one of the latest oxidation process, that is advanced oxidation process, which is used in the tertiary treatment of these effluent treatment facilities. Now this is the preliminary, primary, secondary and tertiary treatments of this effluent. So this is called as overall effluent treatment plant. What exactly the benefits of these effluent treatment plant facilities are? To clean industry effluent and recycle it for further use, to reduce the uses of fresh water in industries, to preserve the natural environmental against pollution, to meet the standards for emission of pollutants set by the government and avoid the heavy penalty, to reduce expenditure on water acquisitions. So we can recycle, we can reuse the wastewater after this effluent treatment facility. We can match, we can comply the guidelines or the legal compliance which is given by the government or the pollution control board, and we can avoid the heavy penalty due to these excess the standards of these emissions, and we can reduce the expenditure on the water acquisition. So these are the different benefits of this effluent treatment plant facilities. Thank you.